Hey guys, welcome back to another video. I know it's been a long time coming, but I finally found a break from school and I'm ready to introduce you to my new series, how to get a 5 on the AP Calculus AB or BC exam. Now, you may be asking yourself, why should I trust you and not watch, I don't know, Khan Academy or Organic Chem Tutor? Well, those are amazing YouTubers and teachers as well. However, I feel that their videos and content isn't exactly tailored to the AP exam, but my content will be tailored specifically to the AP exam. I'll be teaching you everything you need to know to get a 5 on the exam, and I won't add any of that extra stuff that's not on the exam. I'll be teaching you exactly what you need to know and only what you need to know. Now that we have that out of the way, I want to talk about the AP exam content distribution. Now, as you'll see here in the screenshot, each unit is weighted differently on the exam, which means Unit 1 may have more questions than, I don't know, Unit 3, or vice versa. So, based on the content distribution, I'll be focusing more on those respective units which have a higher weighting on the exam so that you can maximize your score. Now, to jump right into the curriculum, I'll be talking about what I'll be teaching you today in this specific video. I'll be talking about limits specifically. I'll be explaining to you what is a limit exactly, and how to determine a limit given a graph, and even given a table. And then after that, I'll be discussing vertical and horizontal asymptotes and limits at infinity specifically. And the rest of the limit content will be covered in the part 2 or maybe even a part 3 section of it.
Alright, well, let's get started with the content. So, okay, let me ask you this. Have you guys ever heard of a limit? Well, that's exactly what I'll be explaining to you today. So I think it'll be helpful to understand it graphically first. Let's have a function or a graph that looks like this. Okay? Now let's take this point for instance. Let's say x is equal to 3 at this point, and at that point also y is equal to, I don't know, 2. Now let's call this y is equal to f of x. Okay? So all a limit is it's telling you the output of a function as you approach a certain x value of the function. Now, that may seem a little bit confusing, but bear with me. Now, we have a way to represent this through math, okay? The limit as x approaches 3 of f of x, which is the name of the graph that we gave. So as we approach the x value 3, what y value are we approaching? Well, as we get closer and closer to 3, we're approaching the y value 2. Now, you may be thinking that the limit is just the value of the function at a certain x value, but that's not it. Okay? Let me be more specific here. Let me make another graph. More simple one. But we have a hole. Now, this hole occurs at x equals 3. Now, let's say that the hole's y value is 5. And let's call this h of x, another function. So I might ask you, and the exam will ask you this as well, so pay attention. The limit as x approaches 3 of h of x. Well, as you know, a hole from pre-calculus is an undefined value, but so you may be tempted to say the answer to this is undefined, but that's not what a limit is. All a limit is what value is the function approaching as you approach a certain x value. It has nothing to do with whether or not that there's an actual defined value. All it's asking is what value we're approaching as we approach an x value. So if we trace the graph and we get closer and closer to x equals 3, what y value are we approaching? That's what the limit's asking. So in this case, as we get closer and closer to x equals 3, we're just approaching 5, right? That's all it is. That's what a limit is. It's that simple, right? Now, let me introduce you to a more complex example. We're still going with the graphs, okay? No, let's... So as you guys know, this is called a piecewise function, okay? Okay, so keep in mind that there are holes in this function, so there's actually some undefined values on this graph. So I want to introduce you to something new as well. They're called one-sided limits. Let me show you an example of one. There's two kinds of one-sided limits. The limit as x approaches -2 from the left of f of x is called this y is equal to f of x. Now you may be wondering, what is this negative sign saying? Well, all that's saying is from the left. So this entire expression is saying what's the limit as x approaches -2 from the left side. So when it's asking from the left side, we can start from the leftmost component of this graph, which is this kind of half parabola. So as we're approaching -2 from the left, what y value are we approaching? Exactly, 1. So that's our answer. Now let's look at the other one-sided limit. Okay, -2 from the right side. Now, as I just gave away, this plus sign is just saying, or is just asking, what value is the function approaching as we approach -2 from the right? So let's start on the rightmost component of the graph and trace our way back to x is equal to -2. So right now, we're not at x is equal to at -2. We're actually at x is a positive 2. So let's keep tracing. Not quite there yet, not quite there yet. Okay, we're close. So let's approach x is equal to -2 from the right. Now, what y value are we approaching? Exactly, -3. So that's our answer. So these are just a couple examples on what one-sided limits really are, and you will definitely have at least 2 questions on one-sided limits on the AP exam. So make sure you know your stuff well, and make sure you're familiar with piecewise functions, not only from a graph but also numerically. They might just give you 2 functions, and you may be asked to find the limit based on that. So right now we're just looking at the graph, but be aware that you will be required to analyze it numerically as well. Now let's look at a limit in a different format. Let's look at a table of values. Let's call this x, f of x, input and output. Okay, let's have, I don't know, -3, -2, -1, 0, 1, 2, and 3. Split this off to make it more visually appealing. Okay, so let's just make up some values, okay? And x is equal to -3. This can be equal to 4 equal to 3. Now let's say that this is equal to 2.0001. And let's actually assume that this is undefined. I'll explain why a bit later. Now let's say that this is also 2.0001. Okay? Now this shoots back up to 3, then this shoots back up to 4. Now, let me ask you, what is the limit as x approaches 0 of f of x? Well, don't let this undefined value scare you, because you have to remember that it doesn't matter. It really doesn't matter what the function is exactly equal to that point. All that matters is what it's approaching. So as you can see, 4, 3, 2.0001, undefined, then back up to 2.0001, then 3 and 4. So it's getting closer and closer to x is equal to 2. So that's your answer. The limit as x approaches 0 of f of x is equal to 2, right? Okay. Now let's examine something called a horizontal asymptote. Now, I'm sure you guys have to have learned this in pre-calculus, but let me reintroduce it. Let's get a graph going once again. Let's see, 6, and this is going to be where a horizontal asymptote is. Let's have a function that asymptotes here. Call this y is equal to f of x. Okay? And I'll also introduce you to limits at infinity. Yeah, that might sound weird, but let me show you what it is in a limit format or limit notation. The limit as x approaches infinity of f of x. Now, all that's saying, I know that infinity is not a number, it's a concept, but all this is saying, what y value are we approaching as our x value shoots to infinity? Well, as our x value gets larger and larger and larger, you can see graphically that our function value is actually approaching 6. So that's all it is. What our value is approaching as our number gets larger and larger and larger, right? Well, there you go. Now, let's look at the other type of asymptote that you've already been introduced to. Vertical, excuse my handwriting, asymptote. Now, let me showcase this to you within the graph. Now, you should hopefully by now know what this graph is. Let me redraw that, that's horrible. Yeah, this is a graph of f of x is equal to 1 over x. Yeah, you're right. So let me bring back one-sided limits once more. What's the limit as x approaches 0 from the left of f of x? Well, let's trace the graph from the left side, the leftmost component. As we trace the graph more and more and more, we realize that as x is approaching 0 from the left side, that our graph is actually shooting down to negative infinity. So that's our actual answer, negative infinity. Okay? Now similarly, we can analyze another one-sided limit, 0 from the right side of f of x. Now let's trace the graph again. Let's approach 0 from the right side once more. And this time we're actually shooting up to positive infinity. Positive infinity. Okay? Now, let me ask you guys one more question. What's the limit as x approaches 0? Now, notice how I'm not telling you from what side. Okay? Now, is it negative infinity as determined by the left side limit, or positive infinity by the right side limit, or is it undefined? Well, I'll answer that question in the next video. We don't have enough time to discuss that, but I'll definitely mention this in part 2. Alright? Alright, so that's the end of the video. I'll be making a part 2 for the limits unit 1, so make sure to have your notifications on, hit that subscribe button, and I'll see you again next time. Thank you.